Your outboard engine can kill you. Breaking down at sea is one thing, but breaking down because your own engine turns on you? That's a whole different ballgame. These engines not only break down, but they're also dangerous. So let's hop into this. If there was ever an outboard engine that sold hope but delivered heartbreak, it was the Chrysler 105 horsepower, marketed as Chrysler's bold response to Mercury's famed inline lineup. It arrived on the scene promising performance and reliability, but what it gave users instead was a tutorial in mechanical betrayal. From day one, the ignition system felt like it had a personal vendetta against boaters. It was fragile, temperamental, and utterly unreliable at high RPMs, right when you needed it most. Starting this engine was a gamble. Restarting it while hot was nearly impossible, and losing spark mid-run wasn't rare, it was kind of expected. Then there was the coolant system, which couldn't keep up under real-world stress. Undersized impellers and poorly routed water channels led to consistent overheating. And salt water? Forget about it. The impellers would struggle to keep water moving, warping cylinder heads and seizing pistons like clockwork. But maybe the most unforgivable flaw? The power head bolts. Whoever positioned those things clearly didn't like mechanics. They were jammed into places you couldn't reach without disassembling half the friggin' engine. Maintenance wasn't just inconvenient, it was borderline sadistic and impossible. Oh, and just when you thought it couldn't get any worse, some of these engines experienced structural failure. Yeah, that's right, fractures at the transom mounts. Some users even watched their engine snap clean off under heavy load. This wasn't just an unreliable machine, it was a dangerous one. The Chrysler 105 HP didn't just damage Chrysler's reputation in the marine world, it helped end their presence in it. But if you thought this was a bad engine, wait till you see the next one. You know, at first glance, the Suzuki 25 horsepower V-twin 4-stroke looked like a step in a bold new direction. I'm talking unique engine layout, 4-stroke efficiency, modern innovation. But all that ambition crumbled the moment you put it on the water. The thing that everybody noticed? The weight. This thing was a tank. Bulky, unbalanced, and heavy enough to drag down a transom on its own. Mounting this thing felt more like attaching construction equipment than rigging an outboard. Aesthetics? This thing looked like two lawnmower engines were duct taped together after a design meeting gone horribly wrong. But let's talk about performance, or the lack thereof. Acceleration on this beast was sluggish, throttle response was dull, and at idle it chugged and stuttered like a tractor with bronchitis. This thing wasn't just slow, it was awkward, making it feel like the engine was constantly one step behind your commands. And then came the catastrophic failures. Bearings wore out prematurely, vibrations wrecked crankcases. Internal stress wasn't just a threat, it was a guarantee. And saltwater cooling systems clogged quickly, with the narrow passages trapping debris and sediment. Overheating became routine, often unnoticed until it was far too late. Eventually, Suzuki abandoned the design, quietly sweeping the V-twin into the history books. Mechanics today still warn new boaters, if you see one for sale, just keep walking. I mean, hey, I'll give them this. Suzuki scrapped the design. Yamaha, on the other hand, they gambled hard and lost big. When Yamaha rolled out the HPDI series, expectations were sky high. High pressure, direct injection promised cleaner emissions, better fuel economy, and serious horsepower. And you know what? On paper, it was everything a modern outboard should be, but reality had some different plans. Let's start with the big one, catastrophic piston failure. Most notably, cylinder number 2. What caused it? A combination of lean conditions from clogged injectors and fuel pump issues. Once those conditions hit, detonation followed, scarring cylinder walls and wrecking power heads. Hell, a lot of users didn't even know there was a problem until the engine locked up at speed. The HPDI's fuel system was a delicate balance, and any debris in the lines, even microscopic particles, could tip the whole thing into chaos. E10 fuel only made things worse. Ethanol attracted moisture, gummed up injectors, and introduced corrosion. You skip a filter change or let the boat sit for too long and you were just asking for trouble. And then came the oiling problems. The lubrication system, for all of its clever engineering and design work, had a habit of failing at the worst possible time. Boaters who finally thought they had a clean run would find themselves drifting mid-journey, engines starved of oil with no warning. To top it off, diagnosing these issues required Yamaha's proprietary tools. Without them, mechanics were flying blind, often replacing parts based on guesswork and prayer. Yamaha improved the HPDI in later models, but by then, the damage was done. The Series 1 earned its reputation as one of the most unpredictable engines on the water. But while some gamble, others think way too much, like Honda, who tried to complicate something that was honestly just good enough. You know, here's one thing Honda usually gets right: reliability. But even the best miss the mark sometimes. And with the early 75-90 carbureted models, Honda missed it hard. These engines introduced an acceleration fault that was as maddening as it was persistent. Under load, the engine stumbled. They ran rough at idle, choked at half throttle, and refused to deliver consistent power when it mattered. The culprit? Blocked jets, tiny holes that clogged easily, made worse by the fact that the plugs sealing them weren't even sold by Honda in the first place. That meant fixing this thing was an ordeal. Mechanics had to drill the plugs, improvise their own tools, reseal the holes manually, all for a fix that should have been basic. Most shops didn't even bother, they just junked the carb and moved on. The result? A growing scrapyard of motors with perfect power heads and busted carbs. Yeah, but the issues didn't stop there. The BF series motors suffered from coil failures in hot environments, leading to mid-ride shutdowns. The engine mounts transmitted harsh vibration into the hull. Cooling issues popped up. And for an engine marketed as premium 4-stroke reliability, it was anything but. Honda addressed a lot of these issues later on, but early adopters were left holding the bill and the headache. But all these previous engines can't compare to what we're gonna see next. The Evinrude G2 should have been a game changer. Clean emissions, bold styling, integrated digital systems, it looked like the future, and it was, just not the kind of future you wanted. Let's start with a gearbox, designed to handle big torque. Instead, it folded under pressure. The clutch dogs wore prematurely, gears stripped themselves down to metal powder, and oil filled with glitter became a common sight in G2 shops across the country. Oh, but it was the powerhead that really stole the show, for all the wrong reasons. High-pressure injectors running at 2,000 psi? Oh, that's great on paper. In practice, they clogged, overheated, and detonated pistons into shrapnel. Engines blew with no warning, and when they did, it was catastrophic. Man, it wasn't rare to see holes punched clean through a cylinder head. The integrated steering system added to the nightmare. When it worked, it was smooth and precise. When it didn't, total chaos. Pressure drops and fluid leaks left boaters with unresponsive helms, making docking or emergency turns a risky move. Oh, then there was the CAN bus wiring, a digital nerve center that turned temperamental and salt air. Water got in, corrosion followed, error codes lit up like a Christmas tree in the middle of December. Mechanics spent hours chasing ghost faults, only to end up replacing entire harnesses at a staggering cost. For one local company, running twin G2 became a business killer. Between blown power heads, long wait times for parts, and loss of customer trust, their operation crumbled. They couldn't run the boats, couldn't book tours, and couldn't explain to customers why their state-of-the-art engines failed twice a week. The G2 wasn't just a bad engine, it was a high-tech implosion that took Evinrude's legacy down with it. Sure, stylish on the outside, unreliable at its core, and way too complex for its own good. Now, if you've ever owned one of these engines, then you know exactly what it feels like to trust a piece of machinery, only left to be stranded, frustrated, or thousands of dollars in repairs. Yeah, these outboards weren't just flawed, they were warnings in mechanical form. A reminder that not every innovation pans out, and sometimes simpler really is better. Got a war story with any of these motors? Drop it in the comments and let's swap some tales. And if you want more brutally honest breakdowns like this one, make sure to like, subscribe, and keep that bilge pump ready, because we got plenty more coming your way.